Dear children, welcome back to the mathematics class. I hope you are doing well at your home. In the last video, we have seen one important theorem in the chapter triangles, that is Thales theorem or basic proportionality theorem, and few more theorems are there. In the syllabus, it is not there in the examination point of view in this year. Okay, so we will learn one more theorem, that is Pythagoras theorem, what you have studied in your previous class also. Today we will see about Pythagoras theorem. So about Pythagoras theorem in 9th standard you have studied and you have heard about this theorem in your previous classes. See, what is this Pythagoras theorem says? This theorem is especially for right angled triangle. Okay, right angled triangle. What is the meaning right angled triangle? If, see, look at this figure. See here, this is a right angled triangle. If one of the angles of a triangle is 90 degree, measurement of any one of the angles of the triangle is 90 degree, then such a triangle is called right angled triangle. This Pythagoras theorem is based on this right angled triangle. So what is that Pythagoras theorem says? The Pythagoras theorem states like this: in a right angled triangle, square on the hypotenuse. So what is the meaning of hypotenuse? The side opposite to the right angle. See, if in this triangle, if it is 90 degree, side opposite to this 90 degree, it is this one, this side. So that is called hypotenuse. See, in a right angle triangle, square on the hypotenuse square on the hypotenuse is equal to the sum of the squares on the other two sides. That is what Pythagoras theorem says. That theorem we have to prove today. Okay. See, this is very important theorem. As I said in my last classes, first part of the statement is always given, second part of the statement is to be proved. So what it says, Pythagoras theorem says, in a right angle triangle, look at this, the statement of that theorem is like this: in a right angled triangle, square on the hypotenuse is equal to the sum of the squares on the other two sides. See, in a right angled triangle, that means there should be a triangle. In a right angled triangle, square on the hypotenuse is equal to the sum of the squares on the other two sides. We have to prove. So a right angled triangle is given. That means one right angled triangle, that is given. That much only given. What you have to prove? Square on the hypotenuse is equal to sum of the squares on the other two sides. See, therefore, data given a right angled triangle. Right angled triangle, say a triangle ABC. If it is a right angle triangle, that angle you have to show. Which angle is 90 degree? See, let us consider this angle B is 90 degree. See, triangle ABC, where angle B is equal to 90 degree. It is given. Okay. So what you have to prove? In a right angle triangle, what you have to prove? Square on the hypotenuse is equal to square on this. What is that square? See, hypotenuse, if it is 90 degree, AC is the hypotenuse. Square on the hypotenuse, AC square. See, AC square is equal to sum of the squares on the other two sides. Sum of the squares. See, square other two sides AB and BC. Sum of the squares means what? AB square and BC square is sum. That means AB square plus BC square. So AC square is equal to AB square plus BC square, or AB square plus BC square is equal to AC square. That is to be proved. Okay. See, to prove this, how you have to prove is one construction you have to do. So you have to construct something. What you have to construct is, see, draw BD perpendicular to AC. You have to construct the B to see BD perpendicular to AC. To this AC, you have to construct what? BD. See, BD. Look at this. BD is perpendicular to AC. That is to be constructed. Draw BD perpendicular to AC. Okay. How to prove? Now look at this. Here, if you draw a construction like this BD perpendicular. Now what we can observe here is this is the original triangle. Is it? See ABC. Is it? This is ABC, our original triangle. Now what you have constructed? One BD perpendicular to AC you have constructed. Then what happens is this triangle again divides into two perpendicular triangles. See again, see one triangle ABD and DBC, two triangles that both the triangles also perpendicular triangles. Why? This is perpendicularly drawn. So here it is 90 degree here. Therefore it is 90 degree. So in this triangle ADB it is 90 degree. In the triangle BDC this angle is 90 degree. Here it is 90 degree because BD is perpendicular to AC. Isn't it? Therefore, the original triangle, right angle triangle ABC divides again into two right angle triangles. Which are the two right angle triangles? ABD. See, look at this. This is the original triangle. I will draw. What is that? One of the triangles I will draw. One triangle is like this. See, A, B, D. A, B, D. Look at this. A, B, D. See, one triangle is like this. Look at this. ABD. I have drawn. Okay. And another triangle is like this. How it is like this? See, BC, and it is like this. See, it is like this. See, again here it is 90 degree. See, so DBC are that two triangles are after this construction BD perpendicular to AC. You will get this ABD and DBC. Both the triangles. Here 90 degree, it is 90 degree. So if it is 90 degree, this is hypotenuse. To this it is hypotenuse. If it is 90 degree, it is hypotenuse, isn't it? Therefore, look here. What you have to do? How do you have to prove that square of the hypotenuse is equal to sum of the squares on the other two sides here? Look at that figures I have drawn. Let us consider in the beginning how you have to prove is. See, in triangle ABC and ADB. See, in triangle ABC, bigger triangle ABC, and one of the smaller right angle triangle ABD. See, ABD or ADB. Let us consider these two triangles. See, I have drawn this triangle and this triangle. One of the parts of the triangle you have to compare. If you compare in triangle ABC and triangle ADB, angle B is equal to angle D. Is it? See, compare this triangle and this triangle, or this original triangle and this part. Angle B is equal to angle D here. Why it is 90 degree? Angle B is equal to angle D is equal to 90 degree. You have tried with the reason. What is the reason? Angle B is equal to 90 degree given in the data itself. Angle B is 90 degree. Angle D is equal to 90 degree. You have constructed. So as ABD perpendicular to AC you have constructed. Therefore, according to angle this data or given data and construction, you can write like this. How you can write? Angle B is equal to angle D. See, in the original triangle, this is the original triangle, this is the part, one of the parts of the triangle, right angle, both also right angle triangles. Next, angle A is common. See, to this triangle and to this triangle, it's common angle. Correct? Is it? See, angle A is equal to angle A. Why? It is common angle. See, here in this, if you compare these two triangles, two angles are correspondingly equal. This angle is equal to this angle. This angle is equal to this angle. Therefore, the third angle I will draw by the third line. See, this angle must equal to this angle. Why? You know, if any two angles of one triangle are correspondingly equal to the two angles of another triangle, that two triangles are equal to each other. Therefore, or similar to each other. Therefore, the third angle is equal to. It's not necessary to prove. If two angles of one triangle are correspondingly equal to two angles of another triangle, then we can say that two triangles are similar. Therefore, we can say triangle ABC is similar. This is a similar symbol. Triangle ABC is similar to triangle ADB. Similar. If you compare that two triangles, if in similar triangles, You have Thales theorem you have learned. If two angles or two triangles are similar, then sides are proportional. Angles are similar. See, in similarity of the triangles you have studied. When we can say two triangles are similar, if the angles are equal, then sides are proportional. So here angles are equal, therefore sides are proportional. So write the proportionality of the side. AB by AD. See, let us consider the AB. What is the corresponding side of this? AB means one and this one single line and this 90 degree. Single line and this 90 degree. Is it corresponding side of this? See, look here. AB is corresponding to AD. See, look at this one and one line and 90 degree here. Therefore, you can write AB in the smaller triangle. It is AD. AB by AD is equal to AC. This is hypotenuse of the bigger triangle. What is hypotenuse of the smaller triangle? See, this is hypotenuse. It lies between 1 and 2 lines. 1 and 2. It is hypotenuse. Correct? Therefore, AC by AB. See, AC by AB. AB by AD is equal to AC by AB. Why? So here how we can say this is equiangular triangle. Both triangles have equal angles. So angles are equal, corresponding equal. Equiangular triangle. Is it? So we can say AB by AD is equal to AC by AB. Now cross multiply AB into AB. Cross multiply like this. If you carry AB here, AB into AB, AB square. If you carry this AD here, AC into AD. So you can write AB square is equal to AC into AD. Correct? Take that one as equation 1. So this is the comparison of original triangle and one of the parts. Okay. Next, let us compare the original triangle with another part of the triangle. With this triangle. See, another triangle. What is that triangle? It comes like this. See, second triangle comes like this. See, it is like this. 90 degree here. This is D, this is B, and this is C. It is like this. Compare these two triangles. Original triangle with this part. See, in triangle ABC and BDC, in triangle ABC and BDC, angle B is equal to angle D. Angle B is 90 degree. Angle D is also 90 degree. See, angle D is equal to angle D is equal to 90 degree. Why? Same reason here. Why? Angle B is equal to 90 degree. It is given in the data. Angle D is equal to 90 degree. You have constructed. Therefore, according to data and construction, you have tried data and construction. We can say angle B is equal to angle D. Next, see angle C. I will rub this. Angle C is common. Angle C is common to both the triangles. Here also angle C. Here also angle C. See, it is common to this part and original triangle. Angle C is equal to angle C. Why? It is common to both, common angles. Is it? Yes, common angles. Therefore, two angles of this triangle are correspondingly equal to two angles of another triangle. We can say these two triangles are similar. Why? The third angle also must equal. Therefore, angle A must, I will draw it by two lines, and it must equal to angle B of the smaller part of the triangle. Small right angle triangle. So angle A is equal to angle B here. Therefore, three angles of one triangle or any two angles of one triangle are correspondingly equal to the three angles of another triangle or two angles of another triangle. That two triangles are similar to each other. How we have written here in the same way, angle ABC is similar to angle BDC. So if they are similar, then what happens? Let us compare the sides. BC. See, here it is bigger triangle BC. What is the bigger triangle BC? Corresponding here, it lies between 90 degree and one line. Whereas 90 degree is here and one line is here. So BC is correspondingly here it is CD or DC. See, BC by BC by in the smaller triangle it is BC is equal to AC. See, AC hypotenuse of this triangle. What is hypotenuse? It is hypotenuse of this. What is hypotenuse here? 90 degrees here, therefore hypotenuse is here. Therefore, AC by BC. AC by BC. Now cross multiply. If you cross multiply, what happens? BC into BC, BC square, and AC into DC. It comes like this. Is it right? So take that as equation 2. Now, so we will prove like this. 1 AB square is equal to AC into AD, BC square is equal to AC into DC. Very simple theorem if you learn. Now let us add both the theorems, both the AB square plus AC into AD, and 1 and 2, equation 1 and 2, if you add, what happens? Let us add the sides, AB square plus here BC square, left hand side. AB square plus BC square is equal to, what is that on the right hand side? AC into AD. AC into AD plus AC into AD plus AC into DC plus AC into DC. AC into DC. Correct? Therefore, AB square plus BC square is equal to, AC is common in both, AC into AD plus DC. We will write like this, AC into DC. Okay. Now, AB square plus BC square is equal to AC into AD plus DC. AD plus DC. See, AD from here to here, DC from here to here. How you can write together? AC. So, AD plus DC is equal to AC. AC into AC. What is AC into AC? AB square plus BC square is equal to AC into AC. AC into AC is AC square. So that one only to prove. AB square plus BC square is equal to AC square. Very simple theorem we will prove. This is what Pythagoras theorem says. So this is very important theorem in the examination point of view. You have to learn this theorem. Okay. It is about Pythagoras theorem. See here, therefore remember children, always in a right angle triangle, square and the hypotenuse is always equal to square and the other two sides. Now here about Pythagorean triplets, some numbers are there. Pythagorean triplets. Pythagorean triplets. What is that Pythagorean triplets? If three numbers are given, for example, 3, 4 and 5 are Pythagorean triplets. What is the meaning Pythagorean triplets? Here you know, in any triangle or right angle triangle, hypotenuse is the longest side always. Its measurement is more than other two sides. Okay, longest side, hypotenuse. Always, whatever may be the triangle, wherever may be the triangle, the hypotenuse in a right angle triangle, hypotenuse is the longest side of the triangle. Okay, therefore, if like this three numbers are given, 5 is the biggest number, therefore we can consider this one as the measurement of the hypotenuse. So hypotenuse square is equal to sum of the squares on the other two sides, 3 square plus 4 square. Is it correct to say? 5 square is 25, 3 square is 9, plus 4 square is 16. See, 9 plus 16 is equal to 25. Square and hypotenuse is equal to sum of the squares on the other two sides. So we can say if one in a right angle triangle, measurement of this side is 3, and if it is 4 units, now hypotenuse is must equal to 5 units. Okay, so 3, 4 and 5 are called Pythagorean triplets. In the same way, many Pythagorean triplets are there. For example, 25, 24 and 7. Look at this. These 4 are Pythagorean triplets. 25. See, it's a hypotenuse. You can consider 25 because it's the biggest number. 25 is the biggest number. These are the smallest number. Therefore, these 24 and 7 units are the sides of other two sides other than hypotenuse. Therefore, can we say 25 square is 625? Correct? 25 into 25 is 625. 24 square plus 7 square now. 24 square. How much 24 square? 24 into 24. 24 into 4. 4 4s are 16. 1 4 2s are 8. 1 9. Then 2 4s are 8. 2 2s are 4. So what is the answer? What is the answer? 576. 24 square is 576. So 24 is equal to 576 plus 49. 9 7 square is 49. What is the answer? 576 plus 49. What is the answer? 5 11 12 2 and 6 625. The answer is 625. So you look at this, 25 square is also 625. 24 square plus 7 square is also 625. So we can say 25, 24 and 7 are also Pythagorean triplets. Okay. So like this, many set of numbers are there. How to check whether they form one right angle triangle or not? Suppose it is given whether the following three numbers are given, whether these three numbers are the sides of the triangle or not. Then what you have to do? You have to check the longest square of the longest sides. That means the biggest square of the biggest number is equal to the sum of the squares of the other smaller numbers. Sum of the squares of the other smaller numbers you have to check. Okay, then if it is equal, then we can say that three numbers are the measurements of the sides of the three sides of the triangle. Okay, like this we will learn. So very simple theorem, you have to learn this theorem properly. Okay, then about notes I will send, you have to write down in your notebook, and some previous theorems are there in the same chapter. Few more theorems are there, that's not included in the syllabus for this year. So after regular commencement of the classes, we will learn which topics are there to learn. Okay, now it is enough, both theorems, one Thales theorem and another Pythagoras theorem. These two theorems we will learn properly, and related questions we will see after the regular commencement, and we didn't get the syllabus properly. So after getting the syllabus, which are the topics or exercise problems are involved in the syllabus, we will learn it later. Okay, it's enough now. I will send the notes, you just copy to your book. So keep reading and stay home and stay safe. Okay, thank you. See you in my next video.